Welcome back to another game design and implementation video. Today we will tackle a bit of a different topic that we have vaguely brushed on in other video forms, that being Unity's Mecanim animation system. I should admit my inspiration for making this video stems from what I consider to be confusing and inadequate reference material on the topic from various forums and guides, so naturally I thought making one for the purposes of teaching it at QUT would be worthwhile. This video will go over the setting up of the animation state machine and some of the tips and tricks for doing this effectively, as well as how to properly use parameters to cast your animations. This process will be done using a very small amount of scripting. We will also go over the use of events and talk about how they can be used to time mechanics more intelligently, as well as how we can employ the use of masks to segregate chunks of a model's skeleton so that we can do simultaneous animations. Just a disclaimer, for this video I am using a pre-built assignment base I have made for my AI students in IGB 383. While I won't be providing this base for download, the relevant material we will set up from scratch anyways. I would recommend that you use whatever model you have in mind instead of following this intricate setup step by step, as all models are set up differently with differing animations, and you will probably employ them for varying purposes anyway. In this base I am using a problematic model that has some great animations, but it is not set up to undertake them in a free and dynamic manner. So we will aim to remedy this without needing to edit the model externally, which is a big deal. Typically you will start work with an animated model by setting up an animator component on your model. Depending on where you received your model from, it may come with an animator model component already, but even then it's usually blank or not set up in an ideal manner for use in a video game. Within the animator component we will need to attach a new controller. So we can create a new controller by right-clicking on your assets folder and going to Create Animator Controller. Name it whatever you want. You can then view this animator controller by clicking on it and viewing it in the animator window. First things first, you are already on a new layer of this animator controller by default. It has been conveniently called base layer, but let's rename it to something more useful like movement. You can have multiple layers animating simultaneously, which is the point of layers, and having an avatar doing multiple simple animations at once is the purpose of Mecanim. These layers have weight, so they are considered in a priority queue, with the greater weight granting higher priority. You should aim to sequence your animation layers sensibly. First we will create an entry state, that's simply being an animation that transitions straight to idle. Now you don't and probably can't do this for all of your models, it's just that this one in particular has said animation and it acts as a nice straightforward starter animation. So by right-clicking in the grey and going to Create State Empty, we can make our first entry transition. Let's rename this to Startup for lack of a better name. I'm also going to attach Sleep to Default. I will also make another state called Idle and make a transition from Startup to Idle by right-clicking on the state I want to transition from. A transition arrow will appear which should allow you to connect to idle. We can test that this is all working by hitting play in Unity. Excellent. Now let's get this thing actually walking. Currently there are two animations necessary to make this thing walk, mostly because there is an idle to walking and then a walking animation. I will make 3 more states, calling them Start Walking, Walking and Stop Walking, so we can smoothly transition back to idling. I can connect the states logically using transition arrows by right-clicking on them. and dragging the transition arrow to the correct state. Additionally, right-click on walking will allow me to set up a transition back to its own state, leaving a small white arrow underneath it. We do this to make sure that the state has itself to transition to when we are currently walking already. In each respective state, I will then attach the animations that make sense, in this case default to walk, walk in place, and default to walk again. Now, default to walk is a one-way animation, and I actually want to play this in reverse. So to do this, I can make its speed negative. This is very convenient if you do not have a return to idle animation provided. One thing to note is that the transition animations here require extensive fine-tuning to get the blending of animations what you would expect. This honestly takes a while and not something I am going to focus on in this video. Just expect to have to fiddle with the animation's transitionary data for some length of time on certain select transition arrows to get the animations you expect. So with some effort, you will have a simple animation transition system set up on a single layer. To get this to work, we will make use of a parameter that we will check in code. Now, I have seen some very unusual and honestly confusing setups provided by other resources which seem honestly a bit overdone. So let's go with a simple check. Either we are walking or we are not. To do this, we will make use of a parameter. By clicking on the parameter tab on the top left of the animator window, you will get the option to make a new parameter with the plus sign. Let's make a boolean and call it walking. Make sure that it is unticked or set to false. Okay, now in the transitions, we check for this parameter by adjusting the transitional conditions. In this case, we want idle to start walking to have the condition walking true, as well as start to walking and walking. So, 3 transitional arrows that check if walking is false. Conversely, when we want to stop walking, we check for walking being false from walking to stop walking and stop walking to idle. And that's it. Parameters are set up to work. To correctly use them, however, we will need to call these parameters in script. This is super simple and the level of control is quite extensive. To test, either adjust your existing movement script or make a new one. At the top, add a reference to your animator component on your avatar and connect it within startup, like so. Then, whenever you are moving the avatar, set the boolean parameter walking to true using the following. Finally, set it to false when you are not walking or effectively become idle. And that's it. We can test our setup in Unity. We now have a walking mech that smoothly transitions between preset animations. We have covered animator events in a previous IGB 100 video, but they were mostly just brushed over. Let's quickly set one up again for the purpose of demonstrating their power. For this, let's use the mech's walking animations to have something happen when its footstep meets the ground. For instance, we might want a sound to play, have some dust instantiate, or maybe have some kind of gameplay variable related to shock to increase, for whatever reason. To do this, we actually need to go to the source of the animation, as this is frame-specific data that isn't easily controllable in the animator component. going to the source of your model, you should find the model with something resembling an animation list. Now, sometimes the animations are separate game objects to the model. That's fine, it will work the same. If we go to our animation in question and expand the option events underneath, we should have the ability to create scripted events tied to specific frames of our animation. As you can imagine, for certain games, this is incredibly powerful and crucial to gameplay. Something like a fighting game or anything that has delayed visual effects, such as on a sword swing animation, may come to mind. We can create an event and call it something useful. We can make events with parameters, but typically we can control for that in scripts anyway. To tie this to our game, we need to make a public method in our GameObjects avatar script with the same name. This will get called every time the animation sequence hits said frame. As you can probably imagine, the utility of this technique is quite extensive and time-saving, as now you can tie game mechanics directly to animation sequences and the speed at which they are performed. Finally, let's discuss a slightly more complicated topic. Sometimes the models you are using in Unity are set up in a non-ideal manner. Typically this involves the creator baking too many parts of an animation sequence into the final sequence, removing the capacity for individual components to animate in tandem with each other. For a more complex game, this is a problem, but not one we necessarily have to fix outside of Unity. As an example, the default setup of our mech for this demonstration has all of its components baked into all of its animations. However, we not only want all weapon animations to be fired at the same time, we also want the avatar to walk or even run and have its torso rotate. The answer to this problem lies in masking. The idea is relatively simple. We wish to mask or hide away bits of the model from the animation data. To unlock masking, expand the mask option for the animation in question and untick the components of an animation you wish to be independent from the rest. Then, for those sections that use said components, simply do the opposite. The final result, providing you expand upon the concepts discussed in this video, set up new layers of animations with different sections of your avatar, is a character that has independently animating segments, like what you might see in a AAA game. It's a bit of work to get happening, but definitely worth it in the long run.